Hello everyone, welcome back to Python Fundamentals episode 7. I am Aditya Thakur. Let's take a second to look at how far you have actually come because it's genuinely a lot. You have mastered every core data type, you know every operator and the exact rules for evaluating complex expressions. You went deep on strings, including slicing methods, formatting, immutability, etc. Your code can now make real decisions with if, elif, else, and match case. And last episode, you learned to repeat actions with for loop and while loops, including a pattern that keeps showing up over and over again, which was starting with an empty list and building it up one item at a time inside a loop. That pattern showing up so often wasn't an accident, it was in preview because today we are covering lists themselves in full depth. Genuinely, the most used data structure in all of Python. If you look at real Python code in almost any code base in almost any industry, be it data science, web development, automation, anything, lists are everywhere. Today, we cover how to create them, every major method for adding, removing, and reorganizing their contents, list comprehension, which is one line shortcut for that exact build a new list loop pattern from last episode. And finally, tuples, which are lists unchangeable cousin. I want to be upfront that this is another long, dense episode, much like our loops episode. That's intentional. Lists are foundational enough that skimming through them now would cost you real understanding later, especially once we read dictionary in episode 8, which build directly on everything we are covering today. As always, code along with every single example, don't just watch. And we have got five full practice rounds spread throughout today's episode, so actually attempt each one before I reveal the solution. That struggle is genuinely where the learning happens, not in watching me type the answer. Here's exactly what's ahead. First, creating and accessing lists, indexing, slicing, and the single most important property of lists, which is that unlike strings, they can actually be changed after creation. Second, list methods, the full toolbox, which include adding items, removing items, sorting, reversing, merging, and a couple of genuinely sneaky bugs I want to make sure you never run into. Third, like comprehensions, once this concept clicks, you will find yourself using it constantly. And finally, tuples, what they are, why they exist alongside lists, and a technique called unpacking that actually connects all the way back to something you learned in episode 2 without even realizing it at the time. By the end of today, you'll be able to store, organize, and transform collections of data, which is generally most of what real programming actually is. So let's get into it. Mo- Moving on to the first part, section 1, creating and accessing list. Let's start with the basics, what a list actually is and how to work with one. Let's create your first list. Fruits equals apple, banana, cherry. Then numbers equals 1, comma 2, comma 3, comma 4. Then mixed equals Sam 25, comma 2, 3.14. Now let's print them. Print fruits, print numbers, print mixed. Now let's run the code. See, we got our lists. See, a list is created with square brackets with items separated by commas. Look at the third example closely. Mixed contains a string, an integer, a boolean, and a float, all in the very same list. Unlike many other programming languages, a single Python list can hold completely different types mixed together freely. Okay, Python doesn't cares about it that much. Now let's move on to the next one. Next one, indexing works exactly like string. Let's try this one. See, in lists, the indexing is just like the indexing in strings. Okay, fruits, print fruits 0. Now print fruits -1. In Python, file and terminal. See, we got apple and cherry. See, fruits 0 gives us apple, the first item. Fruits -1 gives us cherry, the last item. Zero based indexing, negative indexing for counting from the end. This is exactly everything you have learned about string indexing back in episode 4. Just apply to a list instead of string. Let's move to the next one. Next one is slicing the list. Now let's test this example. Numbers equals 10, 20, 30, 40, then 50. Print numbers 1, 2, 3. Print numbers. Print numbers 81. Now let's run the code. See, numbers 1 to 3 gives us index 1 up to, but not including index 3. So 20 to 30 so it gives 20 and 30. Numbers up to 2 gives us everything from startup to index 2, which we got 10 to 20, and numbers step -1 reverses the entire list. This is the exact same slicing syntax from the strings. Start colon, stop colon, then step. Ex exclusive on the end, negative step for reversal. This consistency across data types is genuinely one of the Python's real strength as a language. Now let's move on to the next one. The next one is the critical difference. Lists are mutable. Let's test this code. Fruits equals apple, banana, cherry, fruits 0 equals mango. Now print fruits. See, we got mango, banana, cherry. See, now here's the genuinely important difference. Remember, strings were immutable back in episode 4. You couldn't change a single character in any place. You had to build an entirely new string. Lists are the complete opposite. You can change an item directly using its index right here, like we did here. The fruit 0 equals mango just works. This single property is called mutability. This is really the defining characteristic of list, and it's why they behave so differently from string and tuples, which we'll get to know later today. Now let's move on to the next one. Checking length and membership. Let's try this code. Fruits equals apple, comma banana, comma cherry. Now print length of fruits and print banana in fruits or not. Fruits, print mango. Let's test this one. See, length and in both works on list exactly like they worked on strings. The same two tools from episode 4 now apply to completely different data type. This is a pattern you'll notice constantly in Python. Learn a tool once and it tends to work the same way everywhere it applies. See what happened here. Print length of fruits gave us 3. Then print banana in fruits. Let's check is banana there in fruits. Yeah, there is banana. So we got true. Let's check mango is there in fruit or not. There's no mango in this list. So we got false. Now let's move to the next one. Next one is index error on lists 2. Let's test this code and you'll get to know. Fruits equals apple, banana, cherry. Now print fruits, then 10. See, we got index error. List index is out of range. The same error is the same exact reason as strings back in episode 4. There is no index 10 in a list with only 3 items. Valid indices here are only 0, 1, and 2. Python refuses to guess what you meant and raise an error instead. Now let's move to the next one. Next one is nested list. Let's try this one. See, you'll eventually learn everything while you practice. Okay, so we are just trying every code we find in this PPT and we'll practice that and we'll learn together. Matrix equals 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, comma 8, comma 9. Now let's print matrix of 0. Print matrix 0, 1. See, wait. See, we got the answer. See, list can contain other lists. Matrix 0 gives us the entire first inner list, which was 1, 2, and 3. The matrix 0 and 1 goes one level deeper. First grab the row at index 0, then grab the item and index 1 of that same list within that row, okay, giving us 2. This is exactly how you would represent a grid, a table, or a spreadsheet like structure in Python, okay? The first index picks the row, the second index picks the specific item within it. Now let's move on to the next one. The next one is an empty list and building it up. Let's try this. Shopping shopping list. then print length shopping list, then print type of shopping list. See, empty square brackets create a list with zero items in it. This is generally the standard starting point for the build a new list pattern we use constantly in episode 6. Start empty, then grow it using a loop, or as we'll see soon, a list comprehension. Now let's move on to the next one. Next one is the practice question. Pause the video and just try this question by yourself, and then you can resume the video to check the answer. What's the question? Create a list of your three favorite movies. Print the list in the last movie using indexing. Change the second movie in the list to something else. Print the whole list to confirm the change worked. Oh, let's try this. Uh, Movies equals. Let's suppose first one is I like Inception. Inception. Then Spider-Man. Then uh, let's take an Bollywood movie. Let's take Dhurandhar for an example. Dhurandhar. Print movies. What was the first task? First and last movie. First one zero से होगी. Then second one print movies -1. Last one हो गई. Sir, we have to change the second one ना. Change the second one. Movies. Which movie should I take? Take anyone. Go for. Print movies. Now let's run the code. Wait. Now print movies. Now what happened here? See, see, it got changed. The the original list was Inception, Spider-Man, Dhurandhar. Then we changed it into Inception, Coco, and Dhurandhar. And here we printed the first one, and here we printed the last one. See, movies one, the movie one was Coco, and it directly overrides the second item in place. This only works because lists are mutable. If you tried this exact same thing on string, you would get type error, as we saw back in episode, which was that episode? Episode 4, I remember. Now let's move to the next one. Now next one is list method. Now let's cover the full toolbox of methods that live on every list, adding items, removing items, and reorganizing what's there. Let's start with append. Append, we use append for adding to the end, okay? Let's try one code. Fruits equals apple, then banana, Fruits, fruits dot append cherry print fruits. Now let's Python file and let's run this. See, we got apple, banana, cherry. The original one was apple and banana, and we added the cherry to the last of it. See, append it adds exactly one item to the end of the list, modifying the list in place. No need to reassign it, okay? Uh, this is genuinely the single most commonly used list method in all of the Python. Now let's move on to the next one. The next one is insert. We can add anything at a specific position by using insert. Let's test this code. Fruits equals apple, comma cherry, cherry. Now fruits dot insert one comma banana. Now we have to print fruits. See, insert takes two arguments, the position you want to insert and the value itself. Everything that was already at that position and everything after it. Shifts one spot to the right to make the room. See, we inserted banana in the first index. See, we got banana and the cherry shifted to the right side. Now let's move to the next one. Next one is remove. See, we use remove to delete anything in the list. Let's test this code. Fruits equals apple, banana, cherry. Now fruits dot remove banana. Now let's print fruits. Print fruits. Now let's print the list and see what happens. See, see, removes. We got apple and cherry. See, remove scratches through the list for the first item that matches the value you give it, and deletes that one if the value you're looking for doesn't actually exist in the list. Remove raises an value error rather than selectly doing nothing. It will raise in value error. So it's worth checking within first within first if you are not sure the items exist or not. Now let's move on to the next one. Next one is pop. Pop is used to remove anything by its position. Let's test this example. Fruits equals apple, banana, cherry. Now removed equals fruits dot pop one. Now we'll print the removed one. Remove. And then we'll print the fruits. See here we got banana as we popped the banana. Banana is at first index, so we popped the banana. And while printing fruits, we got apple and cherry. See, unlike remove, which searches by value, pop deletes by position, and critically it returns the value it removed. This is generally useful whenever you need to both take an item out of a list and immediately use that remove value for something else. Now, let's move on to the next one. The next one is pop with no argument. Let's try this one. stack equals 1 comma 2 comma 3, then last equals stack dot pop. Now print last, and print stack. See, we got one and two, and it removed three. See, call pop with no argument at all, and it removes and returns the last item by default. It will return the last item only. This is exactly the behavior used to implement something called as stack, a data structure where you always add and remove from the same end. You'll encounter this concept again if you go further into computer science. But for now, just know pop with no arguments grabs the last item only, and it will remove the last item. Now let's move to the next one. The next one is clear, emptying a list completely. See, now let's test this code first. Fruits equals apple, banana, cherry. Now fruits dot clear. Now print fruits. See, see, clear removes every single item from the list, leaving an empty list behind. This is different from deleting the variable entirely. Fruits still exist as a variable. It's just an empty list now, ready to be built back up. It just we just cleared the list. Now move on to the next one. Next one is sort, which helps in sorting in place. Let's test this code first. Numbers equals 5 comma 2 comma 8 comma 1. Numbers dot sort, print numbers. And now let's do this. Numbers dot sort and reverse equals true. Now print numbers. See, we got the answer. See, this is an important distinction from episode 6. Remember, sorted, which returns a new sorted list and leaves the original untouched. Sort is different. It changes the original list directly in place and returns nothing at all. And reverse is equal to true flips the order to descending instead of ascending. And normal sorts the list in ascending order. And the reverse reverses the list in descending order. Now let's move on to the next one. Next one is reverse, flipping the order in place. Let's test this code. Numbers equals 1 comma 2 comma 3 comma 4 comma 5. Now numbers dot reversed. Now we'll print numbers. We'll get numbers in reversed order. Let's see. What happened here? Oh, not reversed. It is reversed. See, just like sort, reverse modifies the list directly rather than returning a new one. This is the in place counterpart to episode 6, which was reversed function, which just like sorted returned a new reversed version without touching the original one. Now let's move on to the next one. Next one is index and count. Let's test this one. See, fruits equals apple, comma, banana, apple, and now print fruits dot index of banana. Now print fruits dot count apple. See, we got index of banana which was one, and we got count of apple which was two. See, index finds and returns the position of the first match, and counts tell you how many times a value appears in total. If these names sound familiar, that because they are. This is the exact same naming and behavior as the string methods we covered back in episode 4. Now let's move to the next one. Next one is extend. See, by using extend, we merge two lists. Let's test this one out. List 1 equals 1 comma 2 comma 3. Now list 2 equals 4 comma 5 comma 6. And now let's just extend them. List 1 dot extend list 2. Now print list 1. See, we got the extended version. See, extends takes every individual item from list 2 and adds each one into list 1, one at a time. This is genuinely different from append, which we are about to look at as a common mistake. Okay. Now let's move to the next one. Next one is a common mistake: append versus extend. Let's test this one out, then we'll figure it out. List 1, 1 comma 2 comma 3. List 2 equal list 1 append uh, 4 comma 5 comma 6. Now print list 1, print list 1. Let's see what we get. See what we got. We just nested the list inside the first list. That's an error. See, I want to flag this specifically because it's a genuinely common bug. If you see append with an entire list as the argument, Python edits the whole list as a single item, not as multiple items. It creates a nested list, exactly like the matrix example from earlier, when that's almost certainly not what you wanted. If your goal is to merge the values together into one flat list, you need extend, not append. Okay. Now let's move to the next one. The next one is the addition operator and the star operator on lists, asterisk operator on list. Let's test this one out. Addition and multiplication operator. List 1 equals 1 comma 2 comma 3, and list 2 equals 4 comma 5 comma 6, and combined equals list 1 plus list 2. And now print combined, let's just do this one also, repeated equals 0 into 5. Now print repeated. Now let's test this one out, see what we got. See, the plus operator concatenate two lists together into a brand new list without modifying either of two original lists. And the multiplication operator repeats the list contents. Like here, 0 into 0 into 5 gives you 5 zeros. This is genuinely useful for quickly initializing a list of a specific fixed size before filling it with real data. Now let's move to the next one. The next one is copy, avoiding a sneaky reference work. Let's try this out. Original equals 1 comma 2 comma 3, and then reference equals original, and now reference dot append. Now will print original, and yes, this one also save copy is equal to original dot copy. Let's do this one. See, this one is genuinely important and it trips a lot of people. When you write reference equals original, you are not creating a copy of the list. Both reference and original now point to the exact same list sitting in memory. So when we append to reference, original changes too, even though we never directly touched original at all. If we genuinely need an independent duplicate, one that can change without affecting the other, use the copy method instead. Okay. The next one is practice round two. Just pause the video before you watch the answer and just try it by yourself. Let's read the question. Use append to add three item names. Use insert to add fourth item at the very front. Use pop to remove the last item and print what was removed. Finally, sort the remaining list alphabetically and print it. Uh, cart equals cart dot append will append milk to the cart, and cart dot append then will append what eggs. Cart dot append then will append bread. Now let's do cart dot insert. You asked to insert something, no? 0 comma, let's do coffee. And now removed equals cart dot pop. Now print the removed one. Remove. Now cart dot sort, and now print the sorted one. Sort. Let's run the code. Oh wait, print dot cart. See what we got. Popped removed the bread, and what we got? Append milk, eggs. See, coffee, eggs, milk. The last one got popped, which was bread. Okay. See, notice how naturally these methods chain together across a real program. Append builds the builds the list up piece by piece. Insert places something at a very specific spot. Pop removes and captures the last item in one motion, and sort reorganizes whatever's left in it. This is genuinely representative of how list methods get used together in real code. Okay. Now let's move on to the next one. Next one is the next section, list comprehensions. Now, for one of my favorite features in this entire language, list comprehension. This is a one-line shortcut for exact build a new list loop pattern that kept showing up through episode 6. The first one is the loop version. Now let's test this code out. Numbers 1, comma 2, comma 3, comma 4, comma 5, and doubled for n in numbers, doubled dot append n into 2. Now we'll print the doubled one. See, see what we got, 2, 4, 6, 8, 10. This is exactly the building a new list pattern from episode 6. 4 lines of code to double every number in the list. It works perfectly fine, but Python offers a way to complex the file dramatically. See, we won't, because of this, the, what do we call it? The list comprehensions, we won't be needing loops, and it will be much simpler. Now let's move on. The next one is, see, it's the alternate one. Let's test this out. This logic will be on one line, not as loop 3, 4. Doubled equals n into 2 for n in numbers. See, done. Print double, all done. See, we got the same output. Read this out loud, almost like English. Give me n times 2 for every n in numbers. Give me n times 2 for every n in numbers. Same exact result as the 4 line loop version, just dramatically more compact. This is called as list comprehension. Now let's move to the next one. Here we are breaking down the syntax. See, let's just slow down and look at the actual structure here, piece by piece. The square brackets wraps the whole thing just like a normal list. Inside n into 2 is the expression. This is what gets applied to each item. For n in numbers is the loop variable and the sequence being looped over, exactly like a regular for loop. Okay. Every single list comprehension you will ever write follows this same basic shape. It's genuinely a compressed version of the loop pattern you already know completely. Now let's move to the next one. Next one is adding a condition. Now let's test this code out. Uh, Numbers equals 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, comma 8. Events equals n for n in numbers if n%, if n modulo 2 equals 0, even आएगा ना इसमें फिर. It's not events, it's evens. Print the evens number. See, we got the even numbers. See, adding an if clause at the end filters which item actually gets included in the final list. This replaces the counter and filter pattern from episode 6, where you would have checked a condition before deciding whether to append. Now let's move to the next one. The next one is the loop equivalent of the filtered version. Let's try this out. Let's try the loop equivalent. Evens equals Now for n in numbers, numbers, if n percentage equals 0, events dot append will append n, and events equals n. Let's just not type this one. We already typed this one. See, this was 4 line versus 1 line. This side by side comparison. Let's run this out first. Right? See. Oh wait, I have to print also. Print events. No, you'll see. See, 4 lines versus one. This side by side comparison is exactly why list comprehension are so popular among experienced Python developers. Once the concept generally clicks for you, it's very easy, like very easy and very helpful. Now let's move on to the next one. Next one is comprehensions with strings. Let's test this one. Words equals hello world equal Python. Now capitalize equals w dot upper for w in words. Now what will print? We'll print the capitalized version. Print capital. See, let's see what we get. See, we got the capitalized version of this. The expression part of an comprehension can be any valid Python expressions at all, including method calls. Here we are applying upper from episode 4 to every single string in the list. Okay. Now let's move to the next one. Next one is nested loops inside an comprehension. Let's test this code. Pairs equals x comma y for x in range of 2 for y in also in range of 2. Now what we'll do? We'll print the pairs. Print the pairs. See, we got the pairs. 0 0 0 1 1 0 1 1. See, this compresses the nested loop pattern from episode 6 into a single line 2. But I want to be honest with you here. This genuinely gets hard to read first. Use this sparingly and lean toward a full nested loop once things get this complex, okay? You have to use nested loop if things get this complex. Now let's see this. Why not to use a comprehension? Now let's try this with loop. Result equals empty list. Then result equals then for x in range of 10 if x greater than 2 result dot append x into 2 if x modulo of 2 equals 0. Let's print the result. So now print oh, else x equal 3. See, we got the answer. Wait, we have to write this one also. We got this as answer for this loop, and we have to write the other one also. Result equals x into 2 if x modulo of 2 equals 0, else x into 3 for x in range of 10 if x greater than 2. Now let's print this result also. See, we got the same answer, but see, this one is more complex. See, the exact same rule from episode 5, the episode 5th conditional expression applies here directly. Okay, if a comprehension needs multiple conditions and transformations stacked together, a full loop with a real if else is almost always more readable for you right now and for anyone reading your code 6 months from now, including future you. It will be much more readable. So whenever the codes get this complex, just use the loop instead of comprehension. Now let's move on to the next one. Next one is practice round 3. Just pause the video and try this question by yourself, and then you can resume the video as usual. Given the list 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, write a single list comprehension that produces a list of the squares of only the odd numbers. Expected result है 1, 9, 25, 49, and then 81 है. Now, just try this one out first. Numbers equals 1, 2, 3, 4, 5, 6, 7, 8, 10 was also included. 10, then odd squares equals n into this is the exponential, okay, for n in numbers if n% of n modulo 2 equals is not equals to 0. ये odd लेना ना हमने, we have to take the odd value. Now let's print the odd squares. Print odd. See, we got the answer 1, 9, 25, 49, and 81 as the expected result. See, n exponent of 2 is the expression applied to each item that makes it through, and if n modulo 2 is not equals to 0, filter down to only the odd numbers before the squaring even happens. Expression and filters working together in a single line. This was the example of that, okay? Now let's move to the next one. Let's just this check this answer first. Number is equals to this, odd squares is equal to n exponent of 2. Same print old number squares. See, n exponent of 2 is the expression applied to each item, and if n modulo 2 is not equals to 0, filters down to only odd numbers before squaring. एक्सप्रेशन फिल्टर वर्किंग टुगेदर इन वन लाइन हो गया। इसमें पूरा एक ही लाइन में एक्सप्रेशन और फिल्टर हुआ है यूज, ठीक है, सिंगल लाइन है पूरी। नाउ लेट्स मूव टू द नेक्स्ट सेक्शन। नेक्स्ट सेक्शन इज नेक्स्ट एंड लास्ट section is tuples. See, now finally let's cover tuples. This is this unchangeable cousin. We can't just change it. It is immutable. Now moving to the first one. First one is creating a tuple. Let's test this code. Coordinates equals 10, 20. Colors equals red, green, blue. Now single equals 5, comma. See, tuple uses parentheses and parentheses instead of square bracket, as we used square bracket in lists. Pay close attention to that third example. A single item tuple generally needs that trailing comma. Okay. Without it, Python just sees 5 as a plain number wrapped in parentheses, not a tuple at all. Okay. That comma is what actually makes it an tuple. Let's just print these tuples. Wait. We have print coordinates and print colors, and now print single. Print कर लेते हैं एक बार in Python. See, we got the tuples 10, 20, red, green, and blue. Now let's move on to the next one. The next one is indexing and slicing. It works the same way as we learned in strings, as we learned in list. It's all the same. Let's test this code. Print 10, 20, 30. Then print point. Oh wait, it was point, not print. Wait, what I'm doing, I don't know. Point of, but let's do first one first. Then print. Now last one, point of. How do we do next last one? -1. Now print point of 0 to 2. Run Python code. See, we got the answer. 10, then 30, then 10 to 20, 10 to 20. See, everything you already know about indexing and slicing, this applies identically to tuples. The real difference between the two is the one actually matters is coming up right now. Now let's see what happens. The core difference between tuples are immutable. We can't change the object inside tuples. Let's test this code, then you'll get to know. Uh, Point equals 10, 20, 30. Point 0 equals 99. No. एक बार इसको चेक ही कर लेते हैं, टाइपर दे देगा ऐसे विदाउट प्रिंटिंग। See, exactly like the strings which we read in episode 4. Once a tuple is created, it can genuinely never be changed. No item assignment, nothing. This single property is called immutability, and it is really the entire reason tuples exist at all alongside the lists. Now let's move to the next one. Why use a tuple instead of list? Let's check this one first, and you'll know. Coordinates equals 40.71, then negative of 74.0060. This was list, and now let's write coordinates. 0.7128 and minus 0.0060. See, now, so when would you actually choose a tuple over a list? Use a tuple whenever the data generally shouldn't change after it's created. See, geographic coordinates and RGB color value, a calendar date. These are the example when you can use tuples. The immutability itself becomes a form of protection against the bugs. Nobody, so nobody, including you, can accidentally overwrite part of that data later in your program. Okay. Now let's move to the next one. Next one is tuple unpacking. Let's test this code and you will get to know what is tuple unpacking. Point equals 10 comma 20. Now x comma y equals point, and now we'll print कर दो what x, and then print y. See what you got, 10 and 20. See, this is generally one of the most useful tuple feature in entire Python language. You can unpack every value in a tuple into its own individual variable in a single line, okay? Instead of accessing each one separately by index. Now let's move to the next one. Unpacking connects back to episode 2. See, uh, I want to point something out that might genuinely surprise you. Remember multiple assignment back in episode 2 that was secretly tuple unpacking this entire time. Python was quietly creating a tuple 10, 20, 30 on the right side of that equal sign and unpacking it into x, y, z on the left side. You have actually been using this feature since episode 2 without knowing its real name. Now let's move to the next one. Next one is tuples as dictionary, like records. Now let's test this out. Person equals Sam inside the string, comma 25, comma Mumbai, and name, comma age, comma city equals person, and print f. Name is age and lives in city. Let's see what we get. See, we got Sam is 25 and lives in Mumbai. See, a genuinely common real world pattern is this, the bundle related value together as a single tuple. Then uh, unpack them into readable, meaningful, named variable right at the point where you actually need them. See, we did it here. First, we bundled the relative value together as a single tuple, then unpacked them into readable, meaningful, named variable right at the point. Now let's move to the next one. Next one is unpacking. Wait, tuple unpacking. I have done it. Tuples from functions with multiple return values. Let's test this one. Now we are going to try the functions. Def get minimum, maximum numbers, return minimum of numbers and maximum of numbers. And now low comma high equals get min get max, then 4 comma 8 comma 1 comma 9. Now print low comma high. What happened here? What happened over here? Is not defined. Oh wait. See, this is a small preview of episode 9 here. When a function returns multiple values separated by commas, Python automatically packs them into a tuple behind the scene, ready for you to unpack immediately, exactly like we have just did. Okay. Now moving on to the next one. The next one is converting between list and tuple. Let's try this out first. My list equals 1 comma 2 comma 3 comma 4. Tuple equals tuple, then parenthesis के अंदर my list, then let's print my tuple. Now back to list my tuple, print back to list. Let's see what we get. See, first it got converted to tuple, then it got converted to list. See, exactly like the int, float, and string casting functions from episode 2, tuple and list convert between the two types. Okay. This lets you temporarily gain or lose mutability whenever you need to convert to a list to make changes, then back to a tuple to lock it down again. Now let's move on to the next one. Next one is practice round 4. Pause the video and try this. Then after that you can resume the video. Create a tuple representing an RGB color 255, 99, and 71. Unpack it into three variables red, green, blue. Print a formatted sentence describing the color's value using an string. Then try to change the red value directly and observe what happens. Let's try this out on VS Code. Color equals 255, 99, 71. My 7 key doesn't work properly. Then red, green, blue equals color. नाउ प्रिंट स्ट्रिंग के अंदर लिखेंगे R, then we'll red, G, then green, B blue, then color. Wait, what we had to do last? We had to change the red value. See, as tuple doesn't like support item assignment, we won't be able to do that. It will give us type error. Let's print this first. See what we got: R 255, G 99, and B 71. After we do this, color, color 0. Let's see, we got type error. See, the unpacking works exactly the same as any other tuple, but attempting to modify color correctly fails with that type error. See, genuine proof that the immutability we covered earlier is a real. This is a genuine proof of that. Enforced rule in this language, not just a suggestion or a convention. This immutability is an enforced rule. Okay. Now let's move on to the next one. Let's just see this first. Color is equal to 250, red, green, blue, color, print. See. Now moving on to the next one. The next one is the main challenge. Now, just now let's combine absolutely everything from today into one final challenge. Before that, pause the video and attempt this fully before watching the solution. Okay. Uh, Build a simple student grade processor starting with a list of tuples: Sam 85, Alex 92, Joe 67. Use a list comprehension to build a list of just the names where the score is 70 or above. Use a scope with tuple unpacking to print each student's name and their letter grade: 90, 90 plus A, 80 plus is B, and 70 plus is C, and else fail. Print the final passing names list. Now let's try this question. First, I have to remove this one, otherwise I'll get type error. Now, students goals. First one was Sam, no? Sam. He had 85. Then Alex. Alex. And he had 92 something. Yeah. Then we have Joe. He had 67, 67. Then passing equals n for n comma s in students if s is greater than equals to 70. ये हमने comprehension का कर दिया. For name comma score in students if score greater or equals to 90, then grade equals a. If score greater or equals to 80, then grade equals b. If score, oh, alif over here. Alif score equals to 70, then grade is C, else grade equals fail. Now we have to print this also. Print f string, then name, and then grade. Now print the passing. See, we got the answer. See, let's walk through this together. Um, Students is a list of tuples. Each one bundles a name and a score. The comprehension unpacks each tuple directly inside itself. N as in students and filters to it the comprehension unpacks each tuple directly inside itself and filters to only the names where the score qualifies. That gives us Sam and Alex, but not Joe. Then the for loop unpacks every tuple by name into name and score, and then runs them through the exact same if else structure from episode 5 to assign a letter grade. Okay. This challenge genuinely uses nearly every major tool from today, which was a list of tuples for the records, a comprehension for filtering, tuple unpacking inside a loop, and conditional logic from a previous episode. All everything was working together. Now let's move to the next one. Now here comes the recap. Let's recap everything we covered today. Today we covered list in full which in which we covered creation, indexing, slicing, and the critical property of mutability that separates them from strings. We covered every major list method, which were append, insert, remove, pop, clear, store, sort, reverse, index, count, extend, plus the plus and multiply operator, and a couple of genuinely sneaky bugs around append versus extend and then the reference versus copy trap. Then we covered list comprehensions, which was a one-line shortcut for the exact loop pattern that kept appearing through our previous throughout our previous episode. And then we covered tuples. Tuples are immutable, ordered, genuinely protective of your data, plus unpacking, which connects all the way back to multiple assignments in episode 2. In episode 8, we are covering dictionary and sets, key value pairs, every major dictionary method, and set operations. Dictionaries build directly on everything we cover today. So, if list methods and comprehension feel solid to you, right now you are in a genuinely great position. Heading into next episode, hit subscribe so you don't miss it. See you in episode 8. Bye bye. Take care.